Hello, my name is Ashish Vora. Today I am going to present about my project topic, which is a design, modeling, and control of compact and solar microinverter for residential system. My subject code is Engineering9863, and my supervisor name is Mohsin Jamil. Here is all the content about my project topic: abstract, introduction, block diagram, system design and topology analysis, circuit diagram, simulation, PV characteristic, conclusion, and references, which is all topic I cover in my project. So my topic abstract is due to increase the demand for different energy sources, renewable sources have recently gained popularity because of its power saving features and dependability. When it comes to residential sites, the growth of renewable energy will always be more affordable and effective, especially the range of equipment such as inverter panel, batteries, and so on. Therefore, if it is a standalone system or if it is not connected to the grid, the collected energy from various sources needs to be stored in batteries for later use. Analysis for the residential system, design model and control for a small inexpensive inverter for the use of a home. After the project is finished, a small and significantly less expensive microinverter will be used for convert DC power, which is typically received from the battery, in this case into AC power. And this is the introduction of my topic. One of the various components of the PV system is a microinverter. Its goal to change DC into AC. A single solar panel is connected to a single inverter in the system, and the output from several microinverters is aggregated and sent to the grid. The major advantage that microinverters have brought forward is that the inverter module and string mismatch will not take place. Not only that, but it also enables the panel to operate with maximum potential with the higher reliability and efficiency. As even when a panel fails, a perform or it's damaged, the entire system will not come the halt, as every microinverter operates with a single panel at a time. Buck and boost converter are necessary to maintain the DC voltage level for the proper operation of the inverter. In addition to the range of devices will be needed. Therefore, cables become one of the main system issue for the compact and affordable design consideration of the little aspect like number and size of the power electronics parts. So this is the introduction of my topic, which is mostly based on the DC to AC converter, and it's related to microinverter for the residential home. So this is the block diagram. In this block diagram, you can see about the rays of the sun is the put on the solar PV panel, and then it is generate some energy which is also used by charge controller, and it's controlled by the controller, and remaining energy will be storage in the battery bank, and whenever it's required then we can reuse for that purpose, and it's sent to the inverter, and inverter is work for the DC to AC, and after then AC supply will send to the house for the residential purpose. And this is the system design and topology analysis, which is related to all the block diagram. PV panel is linked with the DC to DC with the low supply, and again it is linked to low voltage supply with the battery buffer with the charger, and low voltage supply with the DC to AC HF transformer, and then high voltage is linked with the grid 230 voltage AC and with the 50 Hz frequency. So all this the block diagram is interlinked with together, and it's connect with the controller by to maintain the all the system. And PV panel is the VPV, IPV with link with the controller, and it's also joined with the pulse with modulations with DC to DC, and VB8, IB8. Again, pulse with modulations with the connect with the DC to AC transformer, and then V grid to I grid. This is the circuit diagram of my project, a single stage inverter that performs both the MPPT and grid connection responsibility through a single stage is shown in the figure. The line 1 current is the modulated using the hysteresis current mode control, and then the microcontroller can connect to the grid and perform MPPT using the solar panel. This inverter's efficiency is the 93%, which is very high as compared to other inverter, and the very low total harmonic distances, which is around 4.7%. And sine wave output and power factor is 0.98. Similarly, topology for the single stage microinverter are also presented. It's showing the V in positive to negative, and which is linked to the C in capacitor. Again, it is joined with the T1 and T3 between the D1, and then L1 is joined with T2, and then it's connect with the D2, T5, and T4. It's between the C out, and L out is joined with the V grid. And this is the circuit diagram about my the MATLAB simulation. And in this circuit diagram, I use many uh, different component, which is scoop, VSC controller, 3-bit breed, chalk, and PV array. So firstly, I joined the boost converter control with the uh, IGBT and diode, and PV array also joined with the irradiance, and then it's also connect with the three-level bridge, and then it's connect with the choke and VSC controller, and then a 50 kilowatts supply which joined with the B1, and it's sent to the utility grid for the residential purpose. And you can see the in the bottom of the side VBC B1 is linked with the VABC, and then it is also linked with the PQB1 and PQ to workspace. And this is the simulations of the my project which I done in the MATLAB. It's a graph related to voltage and current. It's showing a sine wave. Both voltage and current is in the same phase in the sine wave. Solar PV characteristic, which is related to current versus voltage graph, and I can see ISC versus VOC, IMPP versus VMPP, and the graph is showing the maximum power output. So it is good for the solar power and characteristic. So it's a steady state analysis of my design. And in this system, I use a different function like a cost summary, cash flow, compare economics, electrical renewable, punctuation, and different cost type and categorize as per the net present and annualized categories is represented by component and by cost type. And you can see in the second image, a cost summary, cash flow, compare economics, which is also showing the quantity, values, and units in respective batteries, string size, string in parallel, bus voltage. And also it's showing the state of charge in respective of the different months, January, February, until the in end of the December. So it's how much energy is consumed at a residential purpose. It's showing in this by systematically average energy cost is zero, and then it's what's the energy is in and out, storage depletions, losses, and annual throughout the is the all things is mentioned in this system. And this is the conclusion of my topic. Data about the rural homes energy use in the Glen from the previous year's electric bill. The plant technology is affordable and simple to implement. Every element employed in this research is easily accessible in the local market. The Homer simulation is run using current data on solar irradiance, temperature, and load at the chosen location. According to the result of the Homer simulations, the planned PV system is capable of powering the chosen rural home throughout the year without using a local utility grid. The planned system is generating 729 kilowatt hours year to power choose home's electric load and charge 41. So this is the different references which I use to make this project. It's related to different micro inverter and string inverter grid connected photovoltaic system. Again, it is the comparative analysis of string inverter and micro inverter for the solar based power system, and also using the different micro inverter and PV plants related literature paper. So which is helpful for me. Thank you.